Hello, this video illustrates running example 5 using the FREESWMM website. To do that, the example's right here and we'll go through it step by step. The first step would be to log into the FREESWMM website. The password, as you remember, is FREESWMM. And we check up here, we got about 30 minutes before it's going to automatically log out. Looks like I was here already. There already is a network file, but we will build a new one entirely as if we were running the simulation for the first time. So we launch EPANET. And it's responding a little bit slow today. There we go. And first step in the example is to load the backdrop. So we'll choose load. And it happens to already be located there in EPANET files. Choose example 5. Click on that one. And that's the same as appears in the example notes. Let's quickly check our notes for our next step. Okay. So we've defaults Darcy Weisbach, liters per second. So let's check those project defaults. Darcy Weisbach, liters per second. Press OK. Import the background, select the reservoir tool, put 2 reservoirs on the map. Reservoir tool, we'll put one here, one here. Node tool, put 2 nodes on the map. One here for the suction side, one here for the discharge side. Select the link tool, connect the reservoirs to the nearest nodes. For the sake of prettiness, I made it curved, but it's just a graphic image. Select the pump tool. This guy. So there's our model as far as the hydraulic space is concerned. Reservoir, pipe, pump, pipe, reservoir. I'll reload the backdrop. Okay, set the total head each reservoir. So we'll make the bottom reservoir 1 meter. We should make it 10 meters, and we'll make the top one 20. That'll be a differential of 10 meters. Oh, it's refusing inputs. Okay, reservoirs are set. Connect the nodes to each other using the pump link. Total head each pipe length, roughness, height, diameter. Let's see if that information is given. 100 meter long, 100 millimeter. Roughness, we're going to use 0.26. I think that's correct for ductile iron. So that one's 4 meters long, 100 millimeters. That one is 100 meters long, also 100 millimeters. Roughness 0.25. That should be good enough. And again, for serious work, we'd actually go look up correct roughness coefficients for the material specification. So the pipe roughness has been set. Pipe length, roughness, diameter has been set. Now we need to create the pump curve. So over here in the menu, there is an option called curves, and we use this button to create a curve. It defaults to a pump curve, but there's several different types. We'll stick with pump. And now we have to provide information. So at shutoff, as you recall, I believe it produces 15 meters a head. Let's check the formula. At 1 liter per second, it will produce 14.9. At 10 liters per second, 10 squared is 100, and then a tenth of that is 10, so 15 minus 10 is 5. So at 10 it produces 5. And it now has enough information to produce an equation representation. 15 minus 0.1 flow squared, which is identical to our problem statement. So choose the OK. Now the curve exists. Okay, select curves, and oh, my step-by-step leaves an important step out, which is to associate the curve with the pump. So we'll go back, and on the pump we will select the pump, open its dialog box, and we have to tell it what curve number to use, and we only have one pump curve, which is number 1. And now I believe our problem is ready to save. So we'll save it as we'll do a slight file name change. This is Jupyter Book Example. And I believe we're ready to run. Our run was successful, and if we pick on a pipe, it'll tell us that our flow rate is 6 liters per second. Keep that in mind, but we'll go ahead and load in the other version. I'll run it. 6.37 liters per second. So we have replicated the problem identically. Let's go ahead and load in the one we just did. And we want to save the network. So now left back in the file place are all the files. There's another bitmap if we want to look at a different way to do it. And I bet if we load in example 5 basic, nope, I don't think this is quite the same, but we'll load in the other backdrop. So all the backdrops are graphic images, and this one's Not quite to the drawing, but you get the idea. Let me go ahead and exit everything. Exit that. And we're now ready to exit the application entirely. And we're done. And that's how you would do example 5.